Hey everyone, welcome to another session of Ceerazzledazzle Physics. In today's session, guys, we're going to be talking about energy stores. So put down today's title, it's going to be energy stores. And before we get going, make sure you hit the like and subscribe button to keep my channel going and keep my content as free as possible. Okay, so what exactly are energy stores? Let's get straight into it. Okay, so what are the different energy stores? That is today's question. Well, we're going to list them right now, all the different energy stores that you need to know. The first one is going to be kinetic. Okay, the second one is going to be chemical. We also have number 3, guys, it's going to be magnetic. Number 4 is going to be elastic, sometimes referred to as elastic potential. Number 5 is going to be thermal. Number 6 is going to be gravitational. Can be gravitational potential, yeah, but we'll just keep it as gravitational. 7 is going to be electrostatic. And it's going to be number 8, it's going to be nuclear. And this is for the new GCSE, guys. So I know in one of my previous videos I've got more of them, but we're just going to be focusing on these, which are the different energy stores. Make sure you understand all 8 of them, guys. So make sure you understand all 8 of them. Okay, now from here I'm going to give an example of each one of them. So kinetic involves things which are moving. So kinetic, things which move. Next one is going to be chemical, guys. Is going to be an example, is going to be in food, because the chemical energy is stored inside the food. Or let's say, for example, we have fuels like petrol, because the chemical energy is stored inside the petrol here. Another good example is going to be a battery. So a battery will also have a store of energy. So just like when you charge your phone, the battery charges up, you've stored chemical energy in there. The next one we're going to talk about is going to be magnetic, and that's going to be do with anything to do with magnets, guys. Elastic, you should be thinking of like, let's say I had like a bow and arrow, when you pull back the rubber band, so that's going to have elastic energy stored, or a spring which has been compressed. So we're going to put down springs over here, and let's say a rubber band over here. Thermal is when things are being heated up, so when things are being heated up, so heat, hot objects. Gravitational is anything which has been placed into the air, which has the potential of falling down. So let's say a book on a shelf. A book on a shelf will have gravitational. Electrostatic, this is to do with charged particles. So let's say I have a proton which has a positive charge, and I take another proton which has a positive charge as well. If I bring them closer together, because they are the same charge, they will repel. So this is going to be charges. This is going to be electric charges. I'm going to put that over here. Electric charges. Nuclear is going to be the energy stored within the nucleus of the atom. So energy stored in nucleus of atoms, over here. Good, so we've got all these examples over here. Kinetic, chemical, magnetic, elastic, thermal, gravitational, electrostatic, and nuclear. And I've got some examples over here to get your head around all of them. But also you've got to be able to identify when energy stores are increasing and decreasing. So now I'm going to go through each of these different energy stores, and I'm going to give you an example when they're increasing and when they're decreasing. Okay, so let's start off with kinetic energy. If a car speeds up, what's going to happen to the kinetic energy store? Well, if the car speeds up, it's going to have a high amount of kinetic energy, so the kinetic energy will increase because it's speeding up over here. What about if a car is slowing down? What's going to happen to the kinetic energy store? Well, that will decrease, so the kinetic energy decreases as well. There we go. So we've got an example when it goes up and when it goes down. What about the other forms of energy? Chemical energy store. If a piece of coal is burnt, what's going to happen to the chemical energy within it? Well, obviously if you've burnt it, that chemical energy within the coal is going to decrease. So the chemical energy decreases. Obviously because you've burnt it, you're losing that energy now, which was stored in the coal. But what happens if you were to charge a battery? So when you plug your phone in and you're charging it up, obviously you're going to store more and more energy inside it. So that's a good example of the chemical energy increasing. That's a good example over here. Right, okay. Magnetic energy stores. Right, this one's a bit different, but hopefully you have a basic idea of magnets, guys. Let's say, for example, you've got a south and a north pole over here, and you've also got a north and a south pole over here. Hopefully you know the fact that if I bring these two together, yeah, if I bring these two together, they're going to be repelled away from each other because they have the same like poles. So when you bring them closer together, they're going to be repelled from one another. So as you bring them closer, obviously they're going to have this magnetic store of energy before they fling off over here. So this is an example of the magnetic energy store increasing because you've brought them close together and they want to fling off. So there's stored magnetic energy and it wants to fling off. What about this one? Let's say if we have two opposite poles are moved further away from each other. So let's say, for example, we had a north and a south here, and over here I've got a north and a south. Well, they want to attract right now, so they're trying to attract right now. They want to move closer together, but you are pulling them further and further away. So you are pulling them further and further away. Well, obviously the magnetic energy between them will decrease. So this is an example of the magnetic energy store decreasing. Wonderful stuff. Right, elastic energy store. So let's say I have a spring, guys, and I compress the spring. Obviously, I've compressed it. It now has the elastic energy stored within it. So when a spring is compressed, the elastic energy store increases, everyone. It increases. Next one, and obviously if that compressed spring is now released, what's going to happen to the elastic energy store? Now that you've released it, there's no more energy that has been contained. So the elastic energy store decreases. Fantastic stuff. Right, thermal energy store. This is pretty easy. This is just when anything heats up. So if the kettle starts to heat up, we know that the thermal energy store, what would you think will happen? Energy store increases. Now, what happens if a kettle starts to cool down? What will happen to the thermal energy? The thermal energy decreases. The thermal energy decreases. Yeah, so the thermal energy will decrease here. Gravitational potential energy store. So let's say I take a book and I put it on a shelf. What's happened to the gravitational energy store? Well, now it's on the shelf, guys. The gravitational energy has increased. So the gravitational energy has increased in this example. The other one now, a book falling down, what will happen to the gravitational energy store? So if the book falls down, it's closer to the ground now, so the gravitational energy store will decrease over here. Okay, now scrolling down, electrostatic energy store. So let's say, for example, I have a positively charged particle over here and I have another positively charged particle over here. So they want to be repelled away from each other. If you are pushing them close to each other, you're going to store some electrostatic energy here. So when you push them closer together, you're going to store electrostatic energy here. And obviously that means the electrostatic energy has increased. So when two like charges, that means the same, are pushed together, the electrostatic energy store increases. Let's say they're oppositely charged now. Let's say you had a positive charge over here and you have a negative charge over here. Okay, so obviously you should identify that positive and negative. They should move closer together, but if you move them further and further away from each other, they can't influence each other. So what will happen is the electrostatic energy will decrease. Excellent stuff. That's when you have two opposite charges being moved further away. That's what will happen here. Right, now, so nuclear energy store. Let's say we have a nucleus of an atom over here. This is the nucleus of an atom, which means the central part of an atom. If that was to undergo decay, yes, and break down, which is called fission. We come across that later on, which means it splits. If this nucleus undergoes decay, it will split and the nuclear energy store within it will decrease. So the nuclear energy store decreases. And last of all, when two nuclei undergo fusion, let's say I was to do the opposite. We're not going to split up the nucleus. Let's say we were to combine two nucleuses together to make something heavier, which is going to be called fusion. This is going to obviously increase the nuclear energy store. So this will increase, the nuclear energy store increases here. So when two lighter nuclei fuse together to make something heavier, so they undergo fusion, not the same as it's splitting earlier on, the nuclear energy store will increase. Fantastic stuff. And that's it for another session of CeerazzleDazzle Physics. Make sure you hit the like and subscribe button to keep my channel going, and good luck in your studies. Ciao, ciao, and goodbye.